Hello, this is Dr. Oz. In this video, I would like to talk about integer linear programs applications, and I will show you capital budgeting, fixed cost, bank location, product design, and market share optimization problems. All right, so let's get started. So capital budgeting problem is a very common problem for any company. Basically, you have limited budget and you are trying to choose the best investment alternatives to maximize your investment return. And we would like to return in terms of maximize our return in terms of net present values. So let's take a look at an example here called Ice Cold Refrigerator Company. And this company is considering several projects for next 4 years. And as all the companies, they have limited capital budget each year. And the management would like to select the best profitable option that will maximize return on investment. And here you can see 4 years cash flows, and these are net present values of those future cash flows. Basically, we are discounting future cash flows into today's dollars. If we go with the planned expansion, for example, project, we will have net present value of $90,000, which is very lucrative in comparison to other alternatives. However, we will spend quite a bit of money in first couple of years. So if we go with warehousing, it has less net present value nor benefit. However, maybe if we spend less money, for example, we spend less money in year one, 15,000 versus 10, 20,000 versus 15, 20,000 versus 20,000, 15,000, 5,000. So we spend less money, but our returns are lower too. So in this kind of capital budgeting problem, we define our decision variables, and these decision variables are binary because we either invest in a project or not. So in this case, P is 1 if the planned expansion project, which is the first project, is accepted, otherwise 0. W is 1 if warehouse expansion project is accepted. M is 1 if machinery project is accepted. R is 1 if the product research project is accepted, otherwise 0. This problem has four constraints, one for each years. So if you write our mathematical model, which is a binary integer linear program model, in thousands of dollars, this is how it would look like. So this is a maximization problem. We are trying to maximize the present value of future cash flows, $90,000 if we go with P, plus $40,000 for W, 10M plus 37R. And the constraints subject to 1, $15,000 initial investment if you go with P in year 1, $10,000 for W, $10,000 for M, and $15,000 for R. And this has to be less than or equal to our year 1 capital budget available, which is given as $40,000. All right. So let's do for other years as well, year 1, year 2, year 3, and for year 4. So for year 2, if I go with P, I need to spend $20,000, $15,000 for W if I go with that, or $10,000 with R. So I don't have any cash outflow if I choose M for year 2. Year 3, if I choose P, $20,000 will be spent. $20,000 if I choose W, and nothing for M again, and $10,000 for R. And this has to be less than or equal to constraints. The year 2 is $50,000 available. Year 3 is $40,000 available. Year 4, $15,000 I need to spend if I go with P, $5,000 for W, $4,000 if I go with M, and $10,000 if I choose R. And this has to be less than or equal to $35,000. Again, these are the constraints, decision variables, P, W, M, or R. these values have to be either 0 or 1. So these are binary decision variables. So that's it for this video. In next video, I will solve this problem using Excel solver. Until next video, enjoy business analytics.